Good morning, my dears. I welcomes you for the today's session about some of the basic concepts regarding to the magnetism. Let's see what are that. That is about magnetic permeability, relative permeability, magnetic field, magnetic intensity, magnetic flux, magnetic susceptibility, Curie temperature. In the previous day, we discussed about what is a magnet, the types of magnets, how the magnets are prepared and discovered. These are all things we discussed in the previous session. So today, we are more discussing about some of the basic concepts in magnetism, that is magnetic permeability. Let's see what is magnetic permeability. The magnetic permeability is defined as the property of the material to allow the magnetic line of force to pass through it. It is a particular property which is defined as allow of the magnetic lines, the magnetic line of force, passing through a certain material. The certain material means magnet. The magnetic line of force passing through a magnetic material is called magnetic permeability. Through a magnet, if the magnetic line of force is passing, that means the magnetic lines are passing, it is a it's not a non-imaginary concept. We can visit in practically we can prove it's not like electrical lines are imaginary, but here these are non-imaginary. You can easily find out the lines which are passing through the magnetic material. So here the lines of magnet of force passing through a magnetic material is called magnetic permeability. It's called magnetic permeability. You can see this figure. See, this is a magnetic material. So through this magnetic material, the lines, see the arrow marks are indicating lines. The lines are passing. The lines which are passing through this magnetic material is called magnetic flux. So here, that is about the definition. The magnetic line of force is directly proportional to the conductivity of material. Here, the magnetic line of force is directly proportional to the conductivity of the material. It is proportional to the conductivity of the material. The magnetic permeability of a material is directly proportional to the number of lines passing through it. So we have another condition also, that is the magnetic permeability is also directly proportional to the number of passing lines. If the number of passing lines are more, then the permeability will be more. So here the permeability depends on two factors. One is the number of lines and the other one is conductivity of material. So these are some of the cases. So this is about the figure illustration where the lines are passing through the magnet from north to south. So here the magnetic permeability is defined with a particular symbol, that is mu equal to B by H, where B is the field, H is the intensity of magnetization. Mu equal to B by H. B is the magnetic field, mu is the permeability, H is the magnetization intensity, where B is the magnetic. It is also defined as magnetic flux density. It is also defined as magnetic flux density. H is the magnetic field intensity. And we have a particular case regarding to this magnetic permeability, that is a good magnetic permeability should have high value of the permeability. So if you want to find a good magnetic material, you want to get a good magnetic material, any good magnetic material will have high value of the permeability, So good magnetic material is consisting of high value of the permeability. The magnetic field intensity is directly proportional to the field density. That is, B is proportional to the that field intensity. So here the permeability units what? That is Tesla per ampere, Weber for ampere meter, Henry for meter. These are the units of the magnetic permeability. The permeability of air vacuum is represented by mu naught. So here you want to, if you want to find out the permeability of a air or vacuum, the air or vacuum permeability is represented by mu naught symbol, which is equal to 4 pi 10 to the power of minus 7. Sorry, this is typing mistake. 4 pi 10 to the power of minus 7 Henry per meter. 4 pi 10 to the power of 10 to the power of 10 to the power of, it is about 10 to the power of minus 7, 10 to the power of minus 7, 4 pi about the mu value 10 to the power of minus 7. This is about the this mu value, so which is Henry per meter. Then after the another important concept about relative permeability. The relative permeability of the material is the ratio of permeability of any medium to permeability of vacuum or air. So here the relative permeability is the ratio between permeability of any medium to permeability of air or vacuum. So here it is mu r can be considered as mu by mu naught. So where mu is the permeability of any medium, mu naught is permeability in a vacuum. So here mu equal to mu by mu naught. So it is expressed as mu r equal to mu by mu naught, where mu is the permeability in medium, mu naught is permeability in vacuum. The another one is, another definition is what? The another concept is magnetic intensity. A magnetic intensity, just already we discussed in the permeability definition. The magnetic intensity at a point is the force experienced by north pole. Force experienced by north pole of unit strength. North pole of unit strength placed at the point due to pole strength of the magnetic material. So here magnetic intensity, simply it is called the intensity nature of a magnet can be considered as a magnetic intensity. It is considered with respect to it at a particular point in the presence of the applied force. The condition we need to consider at north pole. So it is represented by H equal to B by mu. From the permeability concept we define this concept H equal to B by mu. It is also defined as magnetomotive force per unit length. Magnetomotive force per unit length. Magnetic intensity, another definition is magnetomotive force per unit length. It also can be defined as, we have another definition, that is about the degree or extent to which the magnetic field can be magnetized a substance. This is about what? The degree or extent to which a magnetic field can be magnetized a substance. So in the process of magnetization, a process is formed, that is magnetized process. So the strength of the magnetized is called magnetic intensity. We have another definition, that is also, it also can be defined as force experienced by a unit positive charge following with unit velocity in a direction normal to the magnetic field. So this is also one of the definition, that is force experienced by a unit positive charge following with unit velocity in a direction normal to the magnetic field. So these all are the definition. We have many definitions, but here I given only few of the things. So that is magnetic intensity, which is represented by symbol H. The units of the magnetic intensity is what? Ampere turns per meter. Ampere turns per linear meter or per meter. Next, magnetic field. The magnetic field or magnetic flux density is the number of magnetic lines of force passing through normally a unit area of the substance. Unit area of substance. So the magnetic field or the magnetic flux density is the number of magnetic lines or force passing normally through a unit area of substance, which is considered as B equal to mu h. The SI units of this magnetic field or magnetic flux density is what? Weber meter square, Weber per meter square, or Tesla. What is that? Tesla. In CGS units, it is gas. One gas is equal to 10 to the power of minus 4 Tesla. 10 to the power of minus 4 Tesla. Magnetic dipole. What is magnetic dipole? Magnetic dipole consists of two unlike poles of equal strength and separated by a small distance. Magnetic dipole. Any magnet, even the smallest part of the magnet, will consist of two poles. That is the reason it is called magnet is a dipole. A magnetic dipole consists of two unlike poles of equal strength. Unlike poles of equal strength like north and south, and separated by a small distance. They are separated by a small distance. An atom of magnetic material behaves as a dipole due to electrons revolving around the nucleus. Even atom of magnetic material, any magnetic material, smallest particle, here atom means the smallest particle, any magnetic material, any smallest magnetic material behave as a dipole due to electrons revolving around the nucleus. Electron revolving around the nucleus. The two poles of magnetic dipole are magnets. What are the two poles? The two poles of the magnetic dipole or magnet is North Pole and South Pole. Is what? North Pole and South Pole with equal strength. The strength is same. How the North Pole having the similar strength? Sorry. What is the strength of the North Pole? The similar strength will have the South Pole. Means the North and South poles having similar strength, equal strength, and opposite in nature. If the North Pole is a positive, South Pole will be negative. If the South Pole is a negative, the North Pole is a positive. So they are in opposite in nature. The poles opposite in nature. The distance between the two poles of a bar magnet is called magnetic length. So here you are discussing about the magnetic dipole. The magnetic dipole two poles are separated by a smallest length. So that smallest length is defined as the magnetic length of a magnet. Magnetic length of a magnet. It is a vector. It is a vector quantity which is directed from South Pole to North Pole. Sorry, it is spelling mistake. It is directed from South Pole to North Pole. South Pole to South Pole to South Pole of the magnet to its North Pole. South Pole. It is directed from South Pole of the magnet to its North Pole. It is represented by symbol M. It is represented by symbol M. So this is about the magnetic dipole. The magnetic dipole moment is the product of pole. It is a product of pole M. It is another pole M and magnetic length between two poles, whatever length is here, that is 12. So it is a product of pole M and their length. So this is about the magnetic dipole, which is represented by capital M. Capital M equal to M into 2L, where M is the pole strength, 2L is the distance between them. And this is about the figure regarding the dipole. See, North Pole and South Pole both are separated by a particular distance, that is 2L distance. And here South and North poles are having equal strength, but they are in opposite manner. Magnetic flux. Another definition. It is defined as the number of magnetic lines of force passing through a surface. Passing through a surface. If the magnetic lines are passing, then it is called as magnetic flux. It is represented by symbol. Sorry, it is represented in the units of Weber. So this is about the magnetic flux. See, through a surface area, some of the lines are passing. So the lines which are passing through a surface area is called which surface area? Magnetic surface area. So this is about the magnetic flux. So that is B and area. Phi is the magnetic flux, where B is the field, A is the surface area. Sorry. And the another important concept, magnetic susceptibility. The magnetic susceptibility indicates the degree of magnetization of a material in response to an applied magnetic field. In response to an applied magnetic field. Magnetic susceptibility indicates the degree of magnetization of a material in response to an applied magnetic field. Magnetic susceptibility indicates the degree of magnetization of a material in response to an applied magnetic field. It is a ratio between, here it is m by h. We need to consider m by h. It is a ratio between m by h. It is a ratio between m by h. The susceptibility, the magnetic susceptibility, it is a ratio between m by h. So susceptibility chi equal to m by h. This is about chi equal to m by h. The magnetic susceptibility of a magnetic material is defined magnetic intensity m, again same definition, and induced magnetized force h. So here what is h, what is m, that is we discussed. So again it is repeated, sorry. So this is m by h. So here m and h, both the m and h are having same units, that is ampere per meter. M is having ampere per meter, h is having ampere per meter. That is the reason the numerator and denominator having the same units of ampere per meter. So the susceptibility is itself a dimensionless quantity. It is a dimensionless quantity. Why? Because m by m is the units of m is ampere per meter. Similarly, the units of the h is ampere per meter. So ampere per meter. So that is the reason it is a dimensionless factor. So the magnetic susceptibility is a dimensionless factor. And last topic about relation between magnetic permeability and magnetic susceptibility. What is the relation between magnetic permeability mu or magnetic relative permeability mu r and susceptibility? That we need to discuss here. So what is that? We can see here. When a magnetic material placed in a magnetizing field, of magnetizing intensity H, the material gets magnetized. So whenever you are placing a material inside a magnetic field, it will be magnetized. The total magnetic induction B in a material is sum of. So here, whenever it is magnetized, whenever it is magnetized, it generated a particular term. There will be a word will be generated, that is magnetic induction. Due to the magnetic induction, the body will be magnetized. That is magnetized. The body will be magnetized because of the induction. So here the magnetic induction is represented by symbol B. Here the magnetic induction B is considered as the sum of the magnetic induction B naught in a vacuum produced by the magnetic intensity. It is equal to B equal to the magnetic induction. The total magnetic induction in the magnetic material is B, which is equal to magnetic induction in vacuum, that is B naught, magnetic induction in medium, that is Bm. So here in vacuum it is done by the magnetic intensity. In medium it was done by magnetization of material. So here B equal to B naught plus Bm. B equal to B naught plus Bm, where B is the magnetic induction of the total material, which equal to B naught magnetic induction due to the vacuum, B plus B naught plus Bm magnetic induction due to a medium. So here, but from the previous sessions, what is B naught? B naught can be considered as mu naught H. Similarly, Bm is considered as mu naught I. So mu naught H, mu naught I, mu naught H, mu naught I. If you are replacing that values in formula, then B equal to mu naught H plus mu naught I, which where mu naught is a common, then H plus I, mu naught of H plus I, then therefore B equal to mu naught of H plus I. Again, from magnetic susceptibility concept, chi is equal to m by h or I by h. M by h or I by h. It will be m by h or I by h. You can use any of the equation. So here it is m by h or I by h, where m is equal to I. So here I by h, therefore I equal to what? H and chi. So chi and H, susceptibility and magnetizing field H. So H equal to I equal to chi m. Therefore the above equation B is replaced. So the above equation change into what function? It is B equal to mu naught of Y, because we are replacing this value. B equal to, what is B equal to here? B equal to mu naught of H plus I. Then replace the value of I here. Then B equal to mu naught of H plus chi mh. Susceptibility and H, where mu H is the common. What is that? Mu H is the common. Then mu naught H is the common of 1 plus chi m. Then, but what is B? B equal to again mu H. B equal to again mu H, which equal to B equal to again mu H. From the permeability concept or magnetic field definition, B equal to is what? B equal to mu by H. From this condition, B equal to mu H replacing, then B mu H equal to mu naught H of 1 plus chi m. Therefore mu H will be cancelled. What is that? H will be cancelled. Then mu by mu naught equal to this only term will be there. This will be cross multiplication. Then mu by mu naught equal to 1 plus chi m. Therefore mu r. So here, but here mu by mu naught is what? Mu by mu naught is mu r, which is a relative permeability. The relative permeability is what? Mu r equal to mu by mu naught. Therefore mu r equal to 1 plus chi m. Chi means susceptibility of magnet. So this is about this is again a rough process I mentioned here. And what is Curie law of magnetism? Final one. According to Curie law, the intensity of magnetization of a magnetic material is directly proportional to the B. So intensity I and magnetizing induction. As per the Curie law, what is that? As per Curie law, the intensity of magnetization of a magnetic material. The intensity of magnetization of a magnetic material is directly proportional to magnetic induction. Directly proportional to magnetic induction. And inversely proportional to the applied temperature. What is that? The intensity of magnetization is directly proportional to magnetic induction be inversely proportional to the temperature. Inversely proportional to the temperature. Therefore, from this concept, we consider two equations. One is I is directly proportional to B. Another one is I is inversely proportional to 1 by T. From equation 1 and 2, I is proportional to B by T. But B is proportional to. Why B is proportional? Why? Because B equal to is what amount? B equal to mu H. Therefore, B equal to mu H. Is it right? Then B is proportional to H. So B is proportional to H. That is the reason I is proportional to, in the place of B, we are taking H. I is proportional to H by T. Then I by H equal to what? I by H equal to 1 by T. Where I by H or M by H is what? I by H or M by H is nothing but susceptibility. Therefore, susceptibility is proportional to 1 by T. When proportionality is removed, then we are getting equation symbol, equal symbol. Then chi is equal to C by T. Chi equal to C by T, where C is the Curie constant temperature. So this is about the magnetic susceptibility along with the magnetic susceptibility and Curie temperature relation. Okay.